Init involves two arguments that wind up just coming back as straight ahead attributes. So arg1 becomes an object named arg1, arg2 becomes an object named r2, and you'll notice that we're using dot syntax. Self again is a generic placeholder that's going to be substituted in our live code by OC. So we would say OC.arg1 to get back the value of arg1 that was passed into our definition. Same with arg2. So init is again called a constructor, and it gives you your initial set of parameters when you create an instance of a class. Now you're not limited to init. There's a whole lot of other magic methods that you can use to customize the behavior of your class. We're going to talk about that momentarily. But when it comes to actually doing stuff or having your class be able to perform good work, there's where you're going to do your method definitions. And there's nothing magical really about defining a method. You'll notice that the syntax is exactly the same as any Python function right up to returning values. This guy doesn't use the return statement, but you could just as well do that if you needed to return data out of a function. The only thing that makes a method different from a function is that a method is a function definition that occurs within a class definition. That's all there is to it. So it looks like we have a method called printargs taking self, or the current instance, as its argument, and it's going to simply do a printout of arg1 and arg2. So to repeat, let's do this example again. I'll create a name called OC2, and we're going to instantiate our class, and let's say we put in 1 for arg1 and 2 for arg2. We can then do oc2.printargs, and self means that there's no parameters, so it's just open paren, close paren. And this, of course, is Python 2 syntax. In Python 3, we would need to wrap these calls in parentheses because print is a function. But the result of the printargs function would give us back 1 and then 2. It's as simple as that. For this example, we're using a Python script that I've called classes.py. And in this first example specifically, we're creating a class that will ultimately be a superclass or a parent class. But for now, we're just declaring it as a plain old garden variety class. And let's say we needed a class to define a car object. Car or vehicle is a typical example used when folks teach object-oriented programming. So as expected, we're going to open this header line with the class declaration giving a capitalized or title-cased name of our class we're inheriting from object. I'm putting in docstrings, as you see here, at the class level as well as the method level. Our constructor statement is here, and what we're doing is defining init with, of course, the self built-in argument that always needs to be there. And when a class is instantiated, we want to provide year, make, and model is just base information. Generally speaking, most Python programmers will then take those input parameters or those arguments and create names out of them. So I'm creating self.year as a string representation of year, self.make is make, self.model is model, and just for grins and to show you that it can be done, we can add constants in here as well. And in this case, we're creating self.static, which is an attribute or a property that will always return the string constant car data. This middle guy here, I'm getting a little bit ahead of myself. There are plenty of built-in magic methods, as we know, that start and end with double underscore. And one neat thing about these when used in object-oriented programming is that you can format your classes the way you want them formatted. In other words, what happens if we instantiate an object of car, like we're going to do down here, create an NS name, and then what happens if the user or we in our code need to do this? Because by default, this guy is going to come back as a class object, not as a string. And as you know, sometimes data has to be in a particular format to do something in your code. So if we do an strns on a class object, is the code going to blow up? Well, to make sure that that doesn't happen, you can use the magic method str, passing in self, and in this case, I'm returning using C-style string formatting, a line that's going to say string representation is string, 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 self.year, self.make, and self.model. You see? And you can do the same thing if you're working with numbers and you want to make sure that the float works okay, integer. The magic methods are excellent for customizing any conceivable attribute that you need for your class. And then finally, I'm creating an actual honest-to-goodness method here called printCar that frankly, in a sense, does the same thing that the str magic method does. This is going to echo back the full name of the vehicle. And just to spice things up and as a point of review, I'm using the Python 3 string formatting where we call the format method on a string using the curly braces and the positional numbers and passing in again self.year, self.make, and self.model as the objects. Finally, just as a bit of what's called cruft or unnecessary code, but important I think to show you that it can be done, we can invoke the static data, our constant data, very easily using dot notation. I'm also going to have this printCar function print the value of self-static just to show off an attribute fetch. Good deal. Now in this first example, we're going to run the script from here. But then I'm going to show you, which is pretty much what you'll be doing in the real world, using the class as an import object. So in this first example, though, we're going to define a name called NS that instantiates an instance of car, and we're bringing in 1990 Nissan Sentra. We'll then display a string representation of NS. Then we're going to print NS. Then we're going to print out ns.static, and finally we're going to run the printCar method, again using dot notation. So to kind of walk you through what happened, we defined a name called NS and we passed in 1990 Nissan Sentra. The next thing we did is run the str function against NS, and it gave us back our custom string format. After that, we just did a print of ns.static. That was our constant car data. And then we finished with a run of the printCar function, which you'll remember gives us the full name of the object and also, just for cruft's sake, gives us a run of the static data again. Let's now restart the shell to clear out all of our names, and let's import classes. Now, the fact that it ran through the code like this should be no surprise to you, because you'll remember the way module imports work, unless we're doing the main trick, that Python, upon import, is going to run every line of code in that file. And since we had this stuff here, it makes sense that it's going to run it. So what I'm actually going to do is come back, and why don't I just comment out these lines using the triple quote, save the file. We'll come back to Python shell, restart the shell again, and let's import classes, suppress that code, run a dir on classes just to see what we get back. Remember, classes are given first, so we have car, then we have our magic methods, and then we have any standalone functions. You can call the docstring for a class or for a function just by using the dot notation and also invoking the appropriate magic method. $_doc_ gives us that. Of course, we could do just the same thing with the help function, which is syntactic sugar for the doc magic method. That actually gives us more information. Running help on classes.car gives us the class docstring, gives us our methods, init, string, and print